Do I have to do that?
Such geeks.
Can people hear me? Yes. Okay, thank you. All right. Well, I figure that it's a good sign when the breaks start sort of getting longer because people have more and more to talk about. But thank you for coming back. I am Amy Hutchins. I'm the manuscript cataloging librarian for the Schoenberg Institute, and I feel in some ways like the work that I do, which builds on the unmatched work of Lisa Fagan-Davis in cataloging the collection, is sort of a necessary continuation with the past in some ways. However, it is clear from this symposium that the reuse of that data is very much alive in the present and going forward into the future. And in that respect, I will say that working as part of the Schoenberg Institute is an honor and really a never-ending education, both in terms of the collection and my colleagues. So as we, push through to the end of this afternoon, not letting up at all, we are going to be looking more at that future. And I have the pleasant job of introducing Rose McCandless and LP Coladangelo. Rose McCandless is an MLIS student at the University of Denver. She completed her undergraduate degree at The Ohio State University and her MPhil in medieval history at the University of Cambridge. And since September 2023, she has served as the Digital Scriptorium Manuscript Data Curation Graduate Fellow. Rose's research interests include the development of the Vulgate Bible in the 13th century, fragments and fragmentology in the 20th and 21st centuries, and manuscript cataloging in the digital age. She is currently applying to PhD programs to further investigate a transitional period in the history of the Vulgate Bible from circa 1200 to 1230. LP Coladangelo is the Digital Scriptorium Catalog Project and Data Manager and a PhD candidate in Communication and Information at Kent State University. He holds a Master of Library and Information Science degree from Kent State University School of Information and a bachelor's degree from Sarah Lawrence College. In 2021, LP was selected as an LIS Education and Data Science Integrated Network Group Fellow. And if you weren't following along, that spells leading, a leading fellow, developing and implementing a semantic enrichment project for the Schoenberg database of manuscripts, name authority. This research created a linked data network between named entities in the SDBM and Wikidata to leverage both knowledge bases for studying the production and trade of pre-modern manuscripts. LP has authored and or co-authored work published in the journals Knowledge Organization, Journal on Computing and Cultural Heritage, Journal of Library Metadata, the Electronic Library, Proceedings from the Document Academy, Scientometrics, and Data and Information Management. His research interests include knowledge organization systems, metadata, semantic technologies, and information organization and communication behaviors of cultural heritage practitioners. Please welcome our speakers.
Thank you so much, Amy. I'd first like to take a moment to thank Penn Libraries for their fantastic collaboration and for featuring DS at this year's symposium. I also want to thank my colleagues Lynn Ransom, Doug Emery, Jesse Dummer here at Penn. It's such a pleasure to work with you. I'd also like to thank the member institutions of DS for their support of the consortium, which makes this work possible. I'd also like to acknowledge the Gladys Kriebel-Delmas Foundation for their support for this past year, for our Manuscript Data Curation Fellowship, which brought Rose to our team, and for the current support provided by those who have become friends of Digital Scriptorium in contributing to our Manuscript Data Curation Fellowship Fund. With the full launch of the DS catalog, currently at just over 15,000 records from 37 institutions, we are now moving beyond that achievement to make our catalog and the information contained in it more useful and connected, which is the subject of this afternoon's talk. Others have spoken very profoundly on the circulation of manuscripts and texts facilitated by people and organizations. We would like to continue to add to the conversation about the circulation of data about manuscripts, facilitated by technological affordances and reuse by humans and machines. The data we are discussing are actually metadata. That is, the information describing characteristics of a thing or information about a thing's context, which allows us to understand, find, and or use it among many similar things, which remains a key factor in improving access to manuscripts, as well as powering novel forms of digital research. To situate the metadata we'll be using and discussing, let me reintroduce the DS catalog, a linked open database with a front-end search interface mimicking a traditional library OPAC experience. So you'll see here the back end you can find at catalog.digitalscriptorium.org, and then search.digital-scriptorium.org is the front-end interface. Access to this data is possible through searching and browsing the front-end interface, as well as keyword searching or Sparkle querying the back-end linked database. The DS catalog contains aggregated and harmonized records from member contributors who are consortium members of North American institutions with manuscript holdings from global manuscript cultures. Members contribute records describing their manuscripts, which we process by extracting data values, reconciling those values to external data sets to power browsing and searching, and then republish the data as linked open data. As an information scientist in a room full of medievalists and manuscript scholars, I also want to highlight the circulation of ideas occurring in the digital age, which increasingly make disciplinary and domain boundaries porous or even irrelevant. Thanks to digital projects and initiatives, manuscripts are now fully part of the big data era. The growth of and reliance on high-quality metadata about manuscript objects and their historical and cultural context has made significant contributions to the big data paradigm, or the contemporary proliferation of large, heterogeneous, rapidly accumulating data sets used in computational and analytic research. Dimensions of big data are often characterized using various lists of V terms you'll see up there, representing advantages and disadvantages which must be considered and balanced, such as with voluminous yet unstructured data sets or quickly proliferating data without well-documented origins. The challenge for big data research is to take advantage of the positive aspects of big data while mitigating the negatives. For information scientists who study patterns of disciplinary information use, smart data, particularly in the context of the humanities, has been advanced as one such solution. Defined as data which affords insights when analyzed at any level, large or small, it is often the product of expert labor and technological resources that make it structured, so that means machine processable in this context, explicit, that is well described through metadata, enriched, and that could be marked up, annotated, contextualized in some way, and clean, that's corrected, standardized, verified. The extra V that smart data brings to the big data paradigm is value. Smart data research projects in the humanities allow researchers to use existing well-structured and well-sourced small data sets of smart data to make inferences about large-scale patterns or to help answer complex questions. This work can also focus on improving the quality, interoperability, and reusability of data in an effort to increase its value, which has been the focus of smart data work related to vast amounts of metadata produced from what we call gallery, library, archive, and museum, or GLAM communities. Stored and maintained in places like library catalogs and archival records, this data has the advantage of being authoritative, standardized, and well described, rendering it valuable and immediately useful for projects and applications in need of smart data. Manuscript metadata provides an excellent example of this type of data with the potential to be even smarter. This presentation will focus mostly on facilitating a demonstration of a technical and practical example of how DS works to smarten manuscript data for reuse beyond our consortium catalog and to promote discovery within and outside the DS community. In addition to showing the value smart data can bring to the types of questions we as scholars know we're asking, we want to impress upon you the idea in general that any project of this type can generate conditions for greater knowledge creation and sharing by addressing unknown unknowns. When data is presented and structured in such a way that it has the potential for being useful to answer heretofore unasked questions, we are creating solid foundations for future unanticipated insights. Yes, we developed the DS catalog and related projects with certain users, scholars, and audiences in mind. Yet, the ability for our data to be reused in different systems and different contexts should go beyond our initial imagination. Making our data smarter so as to be reusable to unknown users and unknown applications is the start of this process. It is our hope to begin to encourage thinking about data in ways that automatically make its reuse and movement into different disciplinary contexts a more automatic consideration at the point of creation. A significant challenge to connecting and reusing data to make it smarter, however, is the integrity of the bridges built between systems, data models, and data sets known as interoperability. Marcia Zhang, my mentor, offers the following definition. Interoperability refers to the ability of two or more systems or components to exchange information and to use information that has been exchanged. Interoperability can be achieved at different levels of metadata representation, and different tools and strategies can be used to achieve this interoperability at different levels, such that integration of metadata is facilitated by focusing on specific structural and semantic aspects. At the schema level, the focus is on metadata elements, like using crosswalks or application profiles independent of any context of use. So think of this as, what are the characteristics of a thing that we want to describe? And then how do we match them to another set of descriptive characteristics that might exist? Record level interoperability is concerned primarily with mapping records describing one set of metadata elements to another, often converting records between standards. So we have, for instance, a set of, we have a description here that was used, that was created using certain rules. How do we reuse that description in order to describe a resource using another set of rules? At the repository level, such as when records are aggregated from heterogeneous sources or intended to be searched across databases, interoperability can focus both on metadata element crosswalks and value vocabularies. In other words, what are the data values, right? How do we balance both the descriptive rules we're using and the data we have to match another system that uses different rules and affords different data? Methodologically, we have employed mapping decisions at these three different levels through documented crosswalks and metadata repositories. A crosswalk is a visual and textual tool used for translating one metadata standard to another. Don't worry, you'll see one as our talk goes on. Crosswalks are often the form of a chart or a table that is the result of a mapping decision between metadata elements from a source schema to a target schema. Crosswalks facilitate interoperability between metadata schemas and vocabularies by matching equivalents or similar elements or values. So they may also articulate differences or similarities between standards. Crosswalks support aggregation and harmonization of resource descriptions and support systems like union catalogs, cross-domain, and cross-institutional databases. Metadata repositories, or we'll also refer to them as data dictionaries, are databases or infrastructures that store and manage metadata. We maintain metadata repositories as a series of spreadsheets, which record and make accessible the raw materials of our Spartan data by matching string values in member metadata records to external vocabularies and authorities, which are basically standardized ways of referring to entities and concepts. And we use things like the Getty vocabularies, OCLC's faceted application of subject terminology, or FAST, and other standards, which we'll go into a little bit later. The DS catalog, in order to aggregate and harmonize data, is itself constructed through a series of crosswalks and metadata repositories that facilitate reuse and enhancement to publish manuscript metadata in one place using a single flexible structure. The result is a linked open database, which is linked to other linked open databases. Interoperability of member data is supported through transformation into linked data, which is a data encoding structure built on a grammar of triples. Much like many linguistic systems, this has a basic three-part structure of thing one has some relationship to thing two, or subject, predicate, object. Since linked data standards use this basic syntax, entities and relationships from different data models and vocabularies can largely be mixed and matched, as long as the semantics or the meaning of the components makes a triple that's coherent to human understanding. This structure for storing metadata, as you'll, I think, remember from Lisa's talk, is different from other standards like MARC, which evolved out of a bibliographic model of resource description. It has fixed fields and subfields that are primarily for describing books and other library materials. In contrast, linked data standards are much more flexible and interchangeable. So they can describe any kind of resource potentially. MARC has limitations for what it can and cannot describe, so information is sometimes shoehorned in, or fields are adapted to accommodate certain kinds of information they were never meant to take. In contrast, linked data standards are optimized for making all kinds of connections between disparate things because the underlying triple syntax allows for semantic interoperability. Types of things and relationships between things from different models and vocabularies can intelligibly be used together if they follow that triple pattern. So, to summarize our process at DS, we turn structured institutional metadata from member contributors into linked data by extracting metadata values from member records, aligning those metadata elements in their records with corresponding elements in the DS data model, and that's one type of crosswalk we use. That data is in turn enriched by being aligned with corresponding entities and concepts from other authorities and vocabularies, and this is done through our metadata repositories. The resulting enhanced data is published as linked open data in our Wikibase, making it available to be reused in other linked open data projects. Let me go back, yeah. So to back up, let's look at the data lifecycle, which brings us to today's demonstration. A manuscript scholar produces a descriptive catalog. This is high quality data that is relatively unstructured because much of the information is only human readable. A cataloger or metadata specialist at an institution utilizes the description provided by the manuscript scholar to populate a more structured catalog record. And this data is mostly semi-structured, as we call it, because it is machine readable, but it's not necessarily machine processable or actionable. Some data elements may be standardized and structured for machine use, and others may continue to be narrative descriptions usable only to human readers. Additionally, for the data to be reusable between different formats and standards, some work has to be done to convert the data, and that's similar to the way that how DS takes in contributed records to create linked open data records to aggregate and harmonize data from different sources. Records in the DS catalog represent a yet more structured version of the data because they convert data into a more machine usable form, relying on uniform resource identifiers, or URIs. We heard about those earlier, which are essentially web addresses to represent things rather than strings of characters. The use of URIs rather than labels, which is another linked data principle, supports interoperability by providing a means to unambiguously refer to entities and concepts in a machine processable, multilingual fashion. It's really alingual in a way, that uses internet protocols as its basic communication conduit. So think of it as hyperlinks are the links in linked data. Any data that is structured in the same way can be linked to DS data and vice versa without having to translate between data formats or to process natural languages. The Wikibase that the DS catalog uses as its database is essentially an internet-based address book built on triple statements. We give a manuscript object a URI. We use a URI to describe some relationship, like there's an associated name with that manuscript, for instance, like an owner. And then we point to a URI where data about that owner lives. Using other linked data relationships, we can then point to other places where yet more data about that owner lives, such as Wikidata, thus increasing the value of the data by increasing the meaningful connections that can be made between things. Wikidata is also built on Wikibase technology. So Wikidata is essentially an open source, crowdsourced version of the DS catalog, but for all types of knowledge domains. Our DS Wikibase and Wikidata at large have the same basic structure, but have different defined entities and relationships, which necessitated the project that we're presenting today. And a word of caution as we move forward. So you'll see on the left-hand side here, that's a DS record. And what we've done is that we have extracted the data from the DS catalog and then actually mapped it to Wikidata. So what you're seeing is actually two representations of the same physical manuscript. One in the DS catalog, and then the Wikidata version is derived from the DS description, which is ultimately then derived from institutional records, which was ultimately derived from scholarship about that item. And you'll see that there's similarities in the structure here. So an item is given a label, and then there are various statements that are made about them. Remember those triples? So at the top, you'll see, in the top left, you'll see the DS version. So that's the label we've assigned it. It has some identifiers there. And then you'll also see it has a title as recorded. And then we have some information that we'll talk about how we derive that information. And then on the right-hand side, you'll see Wikidata is a very similar structure again. It's given some kind of label, in this case, the signature for the manuscript, and then some series of descriptive information, again, that came from the DS record. You'll want to note that as we move forward, because these are both built on the same kind of software platform, that try not to be confused by when we will use terms like QID and PID or P property value. Those are unique identifiers in Wikibase environments. So Wikidata has its own QIDs and property values, and DS has its own QIDs and property values. So you're going to hear those IDs, and just know that they're not the same between systems. They're different identifiers, but they both use those kinds of designators. Now, it would be a reasonable question to ask why we would need to put the same information into Wikidata when it exists in the DS catalog, which we can link to, right? Here's our reasoning. One, if something should ever happen to the DS catalog, the linked open data is available in another place, alongside and linked to other data in a database so vast that the resources being used to maintain it and maintain this particularly high quality data ensure kind of its sustainability. Two, as we link the DS catalog to another database, we need something in the target database, remember, and that's Wikidata to anchor our data to. So as we're connecting the DS catalog to Wikidata, we basically need a point of contact, which is that Wikidata record. And then from there, other things are linked to that Wikidata record in the Wikidata environment. Three, the data is more easily queryable in one location using one interface to pull down the data, not just about the DS catalog, but any manuscript or any other item that might occur in Wikidata. Four, Wikidata acts as a hub for identifiers, meaning that any other manuscript projects that continue and grow, they can link they can put their manuscript objects into Wikidata, or they can link to other manuscript objects, people, places, other things represented in Wikidata, which in turn makes our data more valuable. And five, the DS catalog, while open source, is not publicly editable, meaning that we maintain a level of control and data quality from the records that are contributed by institutions, but Wikidata, on the other hand, is open for public edits. So that means that anyone can add or change information, and that also means that anyone could have come along and created Wikidata items for these manuscripts, which has both weaknesses and strengths. We thankfully have added the initial contribution of DS manuscript objects based on high quality, authoritative institutional data. The availability of these items in the Wikidata ecosystem now makes the data available to unknown unknowns. Who will continue to use, maintain, add, or even correct data about these manuscripts in that environment is anyone's guess. But the conditions for quality and reusability of the data have been greatly improved because of how smart the data is going in, originating and linking back to DS catalog records, which link to institutional records, which linked ultimately to descriptive catalogs. You'll see that the process for importing DS records into Wikidata is essentially about matching addresses. Remember, these are essentially address books. Where does the thing live in the DS catalog, and then where does it live in Wikidata? And we can leverage that information that's stored in Wikidata and not maintained in the DS catalog. In the case of manuscript objects that are not yet represented in Wikidata, we created a place where that information can exist alongside all of the other things that exist in Wikidata by taking the structured data we had in the DS catalog and repurposing it to live in Wikidata. Thus, reusing, transforming, and connecting data is a strategy for smartening data thanks to an internet-based infrastructure and the grammar of linked data triples, which both support interoperability. As you may remember, I mentioned we needed to employ different mapping methods for interoperability between the DS catalog and Wikidata. The first method we used was matching aspects of the DS data model to a proposed model for representing manuscripts in Wikidata. The second was matching entities and concepts that occurred in our data to their equivalents in Wikidata. And the final piece was using those first two methods to build a template in a software tool called OpenRefine for uploading descriptions of manuscript objects to Wikidata. To show you how this work can be achieved, we, and mostly Rose, will now walk you through the process of contributing DS catalog records to Wikidata, and while describing the concepts and reasoning behind how we complete this work. We're gonna hope to have you witness a live demonstration of some original data which has not been entered into Wikidata but will for the first time for a collection of manuscripts.
Without a doubt.
Everyone pray that it works.
Let's go.
Unlike standard materials cataloging in most institutional libraries, manuscript cataloging is not governed by standards or metadata schemas beyond the guidelines offered by Gregory Pass in the descriptive cataloging of ancient, medieval, Renaissance, and early modern manuscripts, commonly known as AMREM, and other scholarship, including articles and guidance by Ralph Hanna, Orietta de Rold, Consuelo Dutschke, just to name only a few scholars. Manuscripts, as we all know, are complex, varied, unique, and often extremely weird, and this means that the development of an overarching, universally accepted cataloging standard for manuscripts is still a thing of the future. Because of this lack of standardized cataloging practice, institutional descriptive metadata comes to digital scriptorium in all kinds of formats, encoding standards, etc. One institution, for example, may refer to Thomas Aquinas as Saint Thomas Aquinas, died 1274, and another might refer to him as Tommaso de Aquino. Having both of these name formats in one repository, such as the DS catalog, would significantly inhibit search functionality and discovery. What we do, therefore, is reconcile all versions of Thomas Aquinas' name and all other names, places, materials, etc., to a single authoritative URI that aggregates all different versions under the same name and identifier. It is thus our job at DS to reconcile institutional data to our own DS data model to create some standardization across institutional metadata.
Metadata values are extracted from member records, and through a semi-automated process, we match the string values. So you remember those string values on the left, and they're matched to the external vocabulary on the right. We take that external vocabulary, and what we do is we create essentially a very skeletal authority record. So you'll see that on the left-hand side. So we create an authority record in our database, which references the external ID. So it says Wikidata QID Q9438. And that then makes a link between the information. When we get ready to upload a data set from an institution, we run all of their data through a matching process and ingest that. After we do that matching process, we get a single spreadsheet, which is then pushed and uploaded to the Wikibase, and it makes all of those connections, those links possible. When it's ingested into the DS catalog, the original values that were given to us by the institution and the enhanced values are there, so that both can be used for keyword searching and enhancement. So you'll see on the, and oddly enough, let me remove that. Oh, I can't, it's fine. Best laid plans. So on the right-hand side, you'll see the, a list of actually, that's actually sort of backward engineered. You can find what items are linked to it. And so in this case, all of those 20 items are listed as being qualified by an author standardized by Thomas Aquinas. And then there's one of the examples of the items that he's connected to. So this data model that we use supports data reconciliation and enrichment for things like centuries, genres, languages, materials, names and roles, places, subjects, and title standardization.
Because of this process, the data that we upload into the DS catalog is already reconciled to the same data dictionaries and authority resources. This makes the process of mapping manuscript records into Wikidata significantly easier, as the bulk of the standardization work has already been done for upload into the DS catalog. The first step of the process, therefore, of transferring institutional manuscript records into Wikidata has already been done. This means that in order to then transfer the manuscript records from the DS catalog into Wikidata, we needed to map our information to Wikidata on the 3 levels that LP mentioned earlier: data model, data dictionaries, and individual records. Before we get into the nitty-gritty of that actual process, I want to discuss the basic nature of Wikidata just again so that we're all clear. Wikidata, as LP mentioned, is broken into 2 types of data information: properties and items. These items function in triples, and so thing 1 is connected to thing 2. So I wanted to use our illustrious patron as an example. So in Lawrence J. Schoenberg's Wikidata entry, Mr. Schoenberg is the subject. He is thing 1. He is the thing that is being described by his relationships to other things, entities, people, etc. So Mr. Schoenberg has the relationship, date of birth, to the date, 1st of July, 1932. He also has the relationship, occupation, to collector. So that's just kind of the basic structure of Wikidata. And these relationships are a flexible way to describe the relationships between different data points and metadata elements. The difficulty, though, lies in identifying the most appropriate properties or relationships to describe manuscripts and their traits, and in matching the terminology used for items in the DS catalog to the terminology used in Wikidata. The Wikidata model was not created with manuscripts in mind. It is an extremely broad, flexible model that is designed for the possibility of uploading any type of object, record, or thing. Thus, we decided it would be best to use the basic structure, or to base the structure of our manuscript records on an existing wiki-based model, which is called Wiki Project Manuscripts. Wiki Project Manuscripts was developed by 2 classicists based on other earlier data models developed by Biblissima and Marco Hyles. These models, including Wiki Project Manuscripts, take into account the unique structure of manuscripts and recommend how different elements of a manuscript should be represented in Wikidata, taking into account the many specifics of different Wikidata properties and elements that could potentially represent each aspect of a manuscript. For example, would the property production date or the property inception be most appropriate as a property in Wikidata to represent the dates in which a manuscript was created? Spoiler alert, it's inception. This required a great deal of research and conceptual thinking on our part to ensure that the properties we chose, often based on the properties identified by the Wiki Project Manuscripts developers, accurately reflected the relationship between the manuscript and the metadata describing it to the fullest possible extent. Utilizing Wiki Project Manuscripts, existing manuscript records in Wikidata, and other sources on the topic, including a fantastic article by Martin Poulter, we began by simply mapping all of the metadata elements that are represented in the DS catalog to their appropriate Wikidata properties. I built a spreadsheet in which the DS property was matched to the appropriate Wikidata property, which you can see on the screen, and ensured that all qualifiers, which are essentially properties that live underneath other properties to, as the name implies, qualify the data represented by that relationship. Formatting requirements and other relevant notes were included so that all of the information hypothetically necessary for creating a Wikidata entry from a DS record was immediately available in this one document.
While some of the enriched data, such as names and languages that we enter into the DS catalog, is already connected to Wikidata, we also use other vocabularies and authorities. Wikidata is structured in such a way that we need to when we make links in Wikidata, we need to actually link to Wikidata items, so their representation in Wikidata. So if we wanted to say that a manuscript is made from a certain material, we needed to find out how that material is represented in Wikidata, because we use a different authority for that particular material type. At the same time that Rose was leading development of the crosswalk, I was leading and managing work carried out by Justin Blair, who's a former DS graduate assistant, to match some of our authority values to their Wikidata equivalents. And so we created a data dictionary here, matching century values. This is actually places, but we used century values and material values that use Getty Art and Architecture Thesaurus, and place names. In this case, you'll see In the middle set of columns, TGN stands for Thesaurus of Geographic Names. Justin reused a process that I developed similar to the way that we enrich DS data to reconcile the values that we had in TGN or AAT to Wikidata. So the nice thing was that we could basically ask Wikidata, when you have an identifier from the Getty Thesaurus, find it in Wikidata, and then we could pull the Wikidata ID and then make a match. Where there was ambiguity, Rose, Justin, and I met several times to work through problems. So when we couldn't find something, we then did manual searches. So first a semi-automated process and then a manual process. This also required us to make decisions about what we could and couldn't reasonably put into Wikidata because there were limitations between matching vocabularies, but also in terms of the data models. So one was inclusion of genre information in Wikidata required that items need to be classified as genres in Wikidata. So in order for us to be able to make those connections validly, we'd have to go in and make sure that everything we were looking at in Wikidata was actually classified as an instance of a genre, and that would be its own project. So we elected not to do that yet. Additionally, subject information found in member records was not always conducive to addition because sometimes it would be misleading. So for instance, some subject information provided by institutions might be great as a local access point, like a subject heading the city and state of the owning institution, but I don't think that Princeton, New Jersey is what a manuscript's contents are about, right? So that would be misleading to add that as a subject. Titles of works or texts represented in manuscript objects were another issue that we addressed on a case-by-case basis that Rose will talk about. Because physical description, so things like extent of number of folios, length and height and width, layout, that sort of things, because that information is semi-structured in the member records we receive and we simply reproduce that semi-structured data, we would need to parse it. And so that's information that we didn't readily add into Wikidata. So after the crosswalk and the vocabulary mappings, we did some tests with manual data entry. Rose will describe. Data sets from our project were downloaded from the DS catalog using Sparkle queries. And then we put that data into a spreadsheet that we would then upload to Wikidata. And so I can highlight the fact that a version of this query is available on our, we have a query example page, but let me go, but let me go very quickly. So actually what this is I'm not going to go entirely through this long Sparkle query up here, but I'd be happy to talk about it at some point with folks individually or, but what I do want to highlight are the results of that query. So if I go all the way down to running it, go ahead. There we go. So you'll see this is essentially what I extracted. So there's a signature I was able to get, a description that contains, what the manuscript contains, the fact that it's an instance of a manuscript, the fact that, and then you'll see here these URLs represent those material and century types, the place entities, things like dates, script notes. So all the information that we were going to need to enter into Wikidata is part of that Sparkle query.
So once we were satisfied that we had appropriately matched the DS catalog properties to Wikidata properties, I started uploading individual manuscripts into Wikidata using the crosswalking schema that I developed. Can you get it back to the PowerPoint? This helped highlight potential issues and problems with the Wiki project manuscripts model, which was developed primarily for manuscripts with ancient origins containing identified texts with extensive description. That is not the case for many manuscripts represented in the DS catalog. So in the process of manually adding manuscripts to Wikidata, I adjusted the properties, qualifiers, and formatting requirements in our crosswalk to better fit the way that records and their constituent data are formatted in the DS catalog. Once my manual entry test process was complete, we moved on to what was ultimately the goal of the project, developing an upload schema in OpenRefine that allows us to import batches of manuscript records into Wikidata. This required some further adjustments to properties and formatting, namely for the production date property inception, but the result of this process is a consistent crosswalking process from the DS catalog into Wikidata that is essentially the same, regardless of the data set that we are working with. So fingers crossed, I'm going to do a demonstration of this process for you all, uploading the manuscript records for one of our newest member institutions, Vassar College in Poughkeepsie, New York, into Wikidata via OpenRefine. We chose to use Vassar's records for this demonstration because Peter Kidd, the incomparable Peter Kidd, recently compiled a fantastic descriptive catalog of the manuscripts at Vassar. So this set of records provided an interesting opportunity for us to compare the descriptive catalog, the institutional MARC records, DS catalog records, and Wikidata records. Before I arrived today, I got things started by reconciling all of the relevant columns in OpenRefine to Wikidata, with the exception of one. What this means is that OpenRefine is connected with services such as Wikidata, Getty vocabularies, etc., and can match values and entities in an OpenRefine spreadsheet to these vocabularies when instructed. What this does is allows the schema that we've built to automatically link the values that we've contributed, taken from the DS catalog, into Wikidata. It's an important element of Wikidata's linked open data model for the vast majority of items describing an entity to also be Wikidata entities of their own. That's why it's called linked data. Everything is linked to something else. To give you an example of what it looks like when a data point is matched to its Wikidata counterpart, let's look at the matched entity for Bastarda script in Wikidata, which I just clicked into from my OpenRefine spreadsheet. So as you can see, in the Wikidata entry for Bastarda, which is linked to the OpenRefine spreadsheet, as I said, all of the descriptive metadata that has been contributed by other people to describe what this script is and what its external identifiers in other controlled vocabularies are. But some metadata elements can't be reconciled straight to Wikidata because OpenRefine is fallible and makes incorrect matches. To rectify this issue, as LP explained earlier, we have developed standard data dictionaries that match our DS unique identifiers to those for the correct corresponding entities in Wikidata. We can thus use coded instructions to cross-reference the different spreadsheets that contain our data dictionaries and match our DS entities to their Wikidata unique identifiers, and then reconcile to Wikidata from the unique identifiers rather than labels, which is a more precise process. And I'm gonna do a little demonstration to show you how this works. So as you can see, I currently have the QIDs in the place DS column here, if you can see it, in my OpenRefine spreadsheet. These values are the DS QIDs, and just as a warning to everyone, I'm about to say the term QIDs so many times you're gonna hate me, but these values are the DS QIDs, which match to place entities in the digital Scriptorium Wikibase catalog. Remember, as LP mentioned earlier, Wikidata items and DS items have QIDs. They're different QIDs, but they're formatted the same way. What we want to do, in order to be able to reconcile the places associated with these manuscripts to Wikidata, is replace the DS QIDs with the associated Wikidata QIDs, which we have previously reconciled and defined in our places data dictionary. So let me do that. It worked. Our data dictionaries match entities as they appear in the DS catalog, including their label and DS QID, to how they appear in other controlled vocabularies. So OpenRefine enables, no, I already talked about that. Okay. So now that I've instructed OpenRefine, kind of, sort of, I'm just doing this for the demonstration, to replace the DS QIDs with the Wikidata QIDs, I can run the reconciliation process to have OpenRefine match the Wikidata QIDs with their associated labels. So now you can see they're blue, which means that they're reconciled and linked to Wikidata. As I mentioned before, using the QIDs rather than the Wikidata labels for reconciliation is much more secure because the QIDs are unique, whereas there may be multiple entries in Wikidata with the same label. Using the QIDs allows us to avoid accidentally reconciling to the wrong Wikidata entry that has the same label as the item that we're looking for. One of the primary metadata elements that is affected by the issue of multiple identical Wikidata labels is titles. Each manuscript in the DS catalog is assigned a title that represents the content of the texts included in the manuscript, which may be the title of a work, for example, The City of God, or it may be more of a genre term, such as astrology. We're able to include the title as it appears in the institutional data in Wikidata under a qualifier that is associated with the title property, exemplar of. The qualifier is object named as, in which we can input a natural language entity that is not necessarily matched to a Wikidata item. With the titles, however, we have encountered some issues with reconciliation from labels rather than QIDs, and so we have begun work enhancing our data dictionary of standard titles to match our DS titles to the most appropriate Wikidata entry. So, for example, we can match the DS standard title of the Corpus Juris Civilis, Q5057, in the DS catalog, to the Wikidata item with the same label, thereby preventing the automatic Wikidata reconciliation to the entity that has the same label but actually represents a manuscript in the Bodleian Library. Because we have almost 5,000 standard titles in the DS data dictionary, however, this project is ongoing. So, now that we've run the places reconciliation, you can see that OpenRefine has matched the Wikidata QIDs to the associated items. Now that this is complete, we're ready to upload the manuscript records into Wikidata. OpenRefine supports the ability to build a schema that uses the different columns in your spreadsheet, in our example, columns like signatures, shelf marks, places, etc., for the purpose of uploading multiple similarly structured records into Wikidata all at the same time. This schema, once built, can be saved in an individual user's OpenRefine program, so that I can apply the same schema to each institution's dataset easily when it is ready to be uploaded into Wikidata. The schema has the ability, however, to be edited once it has been applied to a new dataset, allowing for flexibility. I've already prepared the majority of the schema for upload, but since we've just reconciled the places column, I need to add this to the schema. Can you do that for me? You might need to reload the page. I already have a place for the places ready to go, which is the property location of creation, which is the recommended property in Wiki project manuscripts that we agreed made the most sense as the property identifying the place in which a manuscript was produced. Sorry. Doing things live is always fun. Okay, perfect. So now that we've input all of our data into the schema, I have to double check all of the content to make sure that I've correctly matched the columns in OpenRefine with their associated Wikidata properties, qualifiers, and references. The schema identifies potential issues with the uploaded data that may not conform to Wikidata's standards. The issues identified in this dataset are all minor and expected. At times, qualifiers may not be included, which typically occurs because the proposed Wikidata property has no content attached to it. In this case, certain works may not have identified authors, for example, so the qualifier author has no content and thus it will be ignored. We don't need to worry about this issue, therefore. Our second issue is the lack of references in certain items. Wikidata, much like Wikipedia, its kind of sister database, requires reference for almost every entity that is added. But because I don't provide references for URIs, so institutional URIs, DS catalog URIs don't need references because they are the reference. So again, I'm not concerned about this issue. Our third issue is letting us know that this edit batch will create new Wikidata items. This is, in fact, the point, so we don't need to be worried about that. So after reviewing our existing issues and ensuring that nothing major is outstanding in the schema, the final step before uploading our manuscript records into Wikidata is to look at the preview. OpenRefine offers the ability to see what a few of the prospective records will look like once we have uploaded into Wikidata, with the actual values that will be included for each property. So we usually just take a look at these to make sure that nothing looks weird, we haven't incorrectly matched anything, everything is reconciled as it's supposed to be. So now that we've double-checked all of our information and it has been organized in the schema, all that's left to do is upload these items into Wikidata. So I am going to do that by hitting upload edits to Wikibase. And I have to add a little descriptor just so that everybody in the Wikidata universe knows that I've done this. And now we're gonna upload my edits. It might take a minute, so I'm gonna keep talking. Once these edits have been uploaded, you'll see that the signature column, Open Refined Spreadsheet, will be reconciled to our new Wikidata entries. We use the signature as the label that in Wikidata, which is essentially the, as I said earlier, like the Wikidata entry for Lawrence J. Schoenberg, his name is the label. So we decided to use the signature because it is the most common way of referring to a manuscript. Oh, look, it worked. Hooray! So now we can click into one of our newly created Wikidata entries for these manuscripts. What just happened?
So no, so yeah, we can click in.
Yeah.
You'll
There
see
you go.
your
Yay.
So there's our manuscript record.
manuscript edits ready.
Yeah.
So now, if I do a Sparkle query, and just to go through this very quickly, what I'm looking for is items that occur in Wikidata. What are they called? What are their identifiers? What institution has them? And when was the item created? So date created means when was the manuscript created? And then a bunch of other, these are triple statements saying, find me all of this information that relates to these variables up top. And so when I run this query, this actually will show kind of a federated search across, in this case, this is looking for French manuscripts. So you'll now see that DS items are in French. DS items are now alongside other manuscripts from other places. So where there's, so you see here, yeah, Bodleian Library, there should be a Vassar item in here, unless I haven't declared Vassar. And then you'll also see another query that I pre-populated here. This is a list of items and then their signatures, their DSIDs, the institution name. And what this represents is not just that we can now gather data across different data sets that actually, we're not connected with the Bodleian Library, we're not connected with these other things, but we can now federate with them through Wikidata, right? So I can search across different data sets for all of these items. But now I can actually append additional information that doesn't occur in a DS record. So I don't have nationalities for these people in a DS record. I don't have places of death. I don't have memberships of where, that they were members of particular clubs or organizations. But that information is in Wikidata. And so I've essentially smartened the data by extending it, by connecting what we had skeletally in DS with a larger, and wasn't even in institutional records, right? Institutional records may have that as biographical or provenance notes, but it's not necessarily connected unless all of this information is literally in Wikidata in one place. Oops.
So one benefit of uploading manuscript records into platforms like Wikidata is the standardization they promote through the rigorous formatting guidelines and the ability to flag inconsistencies that is built into the Wikidata platform. This structure fosters interoperability across institutions and complements the diverse, sometimes unstructured formats of institutional catalogs or finding aids. So how might we use this standardization to better connect disparate collections and enhance scholarly access to manuscript records? And how can this process coexist with the detailed, nuanced descriptions often found in traditional cataloging? As Lisa highlighted in her keynote lecture, developing shared standards for manuscript description is an ongoing goal in our field, exemplified by the establishment of Digital Scriptorium in the 1990s. Traditionally, manuscript cataloging begins with detailed descriptions in institutional contexts, with unstructured data later adapted and transformed into structured data for platforms like the DS Catalog and Wikidata. Could we also explore reversing this workflow, starting with structured linked data, which then is adapted and expanded to create richer institutional records? Would this approach help facilitate interoperability while retaining the flexibility needed to capture the unique nature and contexts of manuscripts? I think the answer is yes. Platforms like the DS Catalog and Wikidata already enhance discoverability by providing centralized access to manuscript metadata. Wikidata, in particular, fosters collaborative scholarship by allowing contributions from a broad community of users. This approach offers exciting potential. Highly structured, machine-processable metadata could serve as a foundation that evolves into more detailed, human-readable descriptions over time. Community contributions, when carefully managed, could significantly enrich our understanding of these objects while maintaining high standards of quality. As our executive director, Lynn Ransom, often says, one of Digital Scriptorium's key strengths is its quick and dirty triage of essential manuscript information: what an object is, what it's made of, and who has been involved in its history. This minimal yet highly structured description acts as a seed, providing a starting point that grows as research progresses and community input expands. When shared in linked open data environments, such data has the ability to connect disparate pieces of information and facilitate broader access and data reusability. Rather than treating structured metadata as an endpoint, we might also consider its role as a starting point for institutional description. Using structured foundational metadata early in the process could streamline workflows and make manuscript records more interoperable across platforms and collections without sacrificing the richness and nuance that detailed institutional records provide. This balance between structured and unstructured approaches could offer a more inclusive, efficient model for collaborative manuscript studies in the digital age. This is not a proposal to replace current practices, but rather an opportunity to imagine how structured and unstructured approaches might inform and complement one another. Structured metadata offers the advantage of scalability, interoperability, and reusability, while unstructured data captures the nuance and complexity that is what we love about manuscripts. I envision a digital environment in which the Wikidata entry for a manuscript serves as a hub, linking data from other resources potentially compiled by separate groups, thereby connecting scholarship and metadata and making it more accessible. What new possibilities might emerge if we prioritize structured data earlier in the cataloging process without sacrificing the detailed, unstructured description that are essential for historical understanding? Others have asked similar questions in their work with structured and linked data, particularly in projects like the Schoenberg database of manuscripts and mapping manuscript migrations. Their efforts, as well as the initial results of this mapping project that LP and I have outlined for you today, highlight how these approaches can coexist and mutually inform. By bringing these questions to this conversation, I hope that we can collectively explore how structured metadata might integrate more fully into existing cataloging practices to create a more efficient and reusable foundation for manuscript description. As this symposium reminds us, digital tools offer the potential to reshape manuscript studies in profound ways. Structured, interoperable data could serve as a bridge, linking collections and connecting scholars across institutions. At the same time, it is essential to maintain the richness and depth of traditional descriptive cataloging. By reimagining how these tools and approaches interact, we may discover new methods to make manuscript studies more efficient, collaborative, and inclusive. To borrow from the manuscript scholar and writer of ghost stories, M.R. James, the life-saving competition is now a thing of the past. Disparate institutional catalogs are often developed via collaboration between scholars and members of this scholarly community, but still exist separately from the descriptions of objects held in other collections. What if we can bring the collaboration that has so often defined this field, and is one of the aspects of the field that I hold dearest, into initial description in a linked data environment? I am confident in our abilities to, as a community, find new ways to use linked data to transform manuscript studies for the better. I look forward to hearing your thoughts on this idea. How can we leverage linked data to enhance interoperability? What workflows would best support collaboration while preserving the richness of our field? And what would a more inclusive and connected era of manuscript studies look like to you? Thank you.
All right, thank you very much. I think we're going to overlap slightly into the break time coming up, since we have the luxury of doing that.
Hi, thanks so much. I thought that was really great, pretty exciting. My question started at the beginning when you were describing how you first were ingesting catalog records, and I was struck by like how important machine actionability is for all that we want to do, but the description of process seemed like we weren't leveraging all that, because it was the scholar keeps doing what they're doing. They just type stuff up in a Word document, and then a librarian comes along and they make semi-structured data, and finally it gets to you, right? And what kinds of things are they doing? They might be like, well, this manuscript has 30 pages in it, and those pages are 10 lines long, and they're just writing that, and then eventually that gets into the structured record. So that didn't sound that great to me, but your aspiration at the very end, I think your question, Rose, was exactly what I was thinking, is that like, to what extent is digital scriptorium ready, or maybe we could, how would it work? Because the best manuscript description actually is generated from making great data about the text that's there, right? So when I write if I wanted to give how many pages it's in, I don't count it up and sit there. We transcribe every page and mark where all the page breaks begin, and then I ask the text, how many pages do you have, right? So the most complete manuscript description is actually the text. I mean, you can add all what the paper is made from and all that you can add that as well, but it's like, how many times is this cited in the manuscript? How many references are there? Like, we could go observe that and count it up, or we could make a text that's machine actionable and it will answer all those questions for us. So if we had a triple store of all of that information, how do we connect it to the digital scriptorium? And maybe the other question is, do you have a vision of other partners for this data collection that aren't libraries? Because it seems to me that like right now our vision of who would make data to this is like always the institution that owns the thing. And I think in the future, or even now, like that's not the case, or might not be the case as much now. So I don't know if that question makes sense, or.
I think there's like 5 questions in a good way.
That's
So,
Jeffrey.
yeah, so let me try to address some of it. And one is to say that there's a shadow agenda to show how insufficient the descriptions are to begin with to be machine actionable, right? So in some ways, this is like a call to action to say, we can do some pretty cool things with federating searches, but ultimately the kind of things that you were mentioning and talking about are what's needed to think more readily about how we get immediate structured data as opposed to filtering to structured data. I also want to manage expectations about what DS is and isn't. So what we are is an aggregated and harmonized, National Union catalog of manuscripts. We're not adding to the data, so it would be institutions maintaining their own data, and then from there, we enhance the data for discoverability, but we're not adding any additional scholarly annotations or anything of that nature. So where that can happen, I think, is in other people's data sets. And so what I want to emphasize is, if we reuse data and we put it in different places and we make it available to different audiences and to different people, then that means that scholars themselves can make their bespoke data sets based on the thing they learned from over here, and the thing they learned from over here, and the thing they have from here, and the thing they have from their private notes, so that there's an easy way to be able to connect all of that. The fact that there are standard identifiers, or it's all in a linked data environment. I don't think we're ever going to have a one solution fix, or a one database to rule them all, in part because databases are built with certain kinds of epistemological assumptions in mind. So you have a viewpoint about when you build something. When we built the DS catalog, we had certain ideas about what we wanted it to do and what we didn't think it could or should do. Other people's databases will have other assumptions built in. Wikidata has the assumption that it's crowdsourced and you can have parallel description, you can have more than one kind of property and different viewpoints reflected in the same thing, whereas the DS catalog is saying this is just the institutional record. So because they're represented in two different places, there's two different kinds of data that can ultimately represent different kinds of viewpoints based on the fact that those databases are structured differently. So I want to emphasize that I think the connections are made by the individual scholar in terms of where can they collect data from, but how easily can it be connected and enriched because that data is ready to go in terms of making connections.
I think also just to very briefly answer your question about institutional ownership, I would love to live in a world in which private collectors shared their data and their manuscript collections as openly as Mr. Schoenberg, but as we've already discussed, that's not our reality. So honestly, I think I don't want to put the cart before the horse and kind of think conceptually about how we can make these things happen for institutional collections. And once that would be hypothetically implemented, kind of moving out to consider the trade and private collections and other things like that.
Arthur, and then I'll come back.
Congratulations.
Thank you.
I've been trying and failing to do a lot of what you've been doing for about 25 years. And so I just thought I'd put to you a couple of problems that I faced, wondering how you've addressed them. You may have already made decisions, but I'm just wondering. Two data points. One of them is vernacular script, and the other is place name. And part of the issue is, let's say, the assumption of neutrality, that data is neutral in its sort of political values. So I saw a description. I did see one vernacular font. I don't know the script, but maybe it was Chinese or something like that. Mm-hmm. But you had descriptions of different kinds of languages in English, and we were talking yesterday about the audiences that may be able to access and read these things. And I don't know if it's something that artificial intelligence could do, but that DS is essentially a Anglophone structure. Both in its intended audience, but also in its representation of a non-Roman language, non-Roman fonts, script types. So that's my first question. How do you deal with vernacular language presentation? And the second one has to do with the politics or the sort of political gazetteer, which is when you say place, who controlled that place at what time? And because political control is such a contested issue, and historically boundaries change, and so different people at different moments may consider a place to belong to them, and someone else may say it belongs to them. Mm-hmm. And so while I very much embrace this kind of metaphysics of harmony, I'm always confronted by the dissonance. And so I'm really wondering how you deal with speaking in multiple languages in their own shape and form, and dealing with the contested places that these manuscripts come from. Thank you.
So to address where, say, vernacular representation of names and titles comes from, so largely that will come from MARC data or TEI data that is then extracted and qualified in our Wikibase as, here's the title in English, and then here's a qualifier that is in original script, and then that original vernacular script is if Arabic or Chinese or what have you. We don't enter that into Wikidata. I don't think we have an intention to do that, in part because it's not going to be easily representable in Wikidata, but it is represented at least in terms of searchability in DS. And so again, I want to emphasize that databases cannot, because they're built in with certain kinds of assumptions, they can't fix every problem and do everything that you would hope that they do. So when it comes to to that kind of representation. We can do it in one place because we can, easily, because we have more control over the data versus, and the model versus what is happening in Wikidata, and there might not be a great way to kind of plug that information in. You could do it in the way that that Rose mentioned, where object named as is a qualifier for a particular exemplar of. So you could create an object named as in the catalog, in some cases would be an English title or a vernacular title if you're talking about the titles of works. When it comes to places, I can speak to the fact that, again, this is just because of the decision we made for the DS catalog. It is, we reflect whatever decision or whatever data matches what is in the original record, and then whatever matches in in TGN. And then if we don't have a good match, we don't make a match in terms of enriching the data. Now, when we were making matches between TGN and Wikidata, often we would come across what, I don't think this addresses necessarily place names in a political way, but it does address it in a historical way, where Wikidata is more likely to have different kinds of political entities represented over time in different ways. So they'll have, I think you saw in that one listing of like nationality and ownership, it'll say Great Britain, but it'll say like Kingdom of Great Britain and Northern Ireland or something like that. And they're listed as separate entities in Wikidata, whereas say in TGN, that might not be the best case, but they might be listed as one place. So we found ambiguity in that respect, and then had to make decisions where we said, okay, we think this accords best with this historical or political entity. If that's wrong in the Wikidata environment, someone will correct it, and that's up to the community, because that is a crowdsourced space to be able to police that. So we're putting this data out into the universe and saying, we think this is authoritative, we think it's correct, but folks have at it, and then may have those political discussions and have those discussions in Wikidata, or while the DS catalog is representing, another kind of space where we're at the sort of a luxury of not making those decisions because it's just reflective of institutional data.
Is there a plan to make a public statement to that effect? So if people were to criticize DS, I'm sorry. Like this, if this language offends you,
Yeah.
there are various kinds of statements we now see in cataloging records,
Yeah.
effort to make descriptive cataloging
Yeah.
offensive and whatever.
In a soft way, I think we don't say it explicitly, but we do say it by saying that if you find discrepancies in the data, that is because it's institutional data. So we are not doing anything to change the string values that come in. If you found discrepancies in terms of the enrichments, sure, and then we could, have those. We've kind of talked a little bit, because we keep our data dictionaries on GitHub. Somebody on the board actually floated the idea of like, would we allow pull requests or making corrections that way. So I'd say for right now it hasn't come up, but I'm interested in learning more about, when people are concerned, what the mechanism will be for addressing it.
Thank you.
Yeah.
First of all, I want to say nice work, guys. Way to go, and I'm really excited to see what you've been doing. One of the things I think that we kind of take for granted, the people that especially worked with the rebuild, is that we understand Digital Scriptorium to be basically a finding tool. You've heard Lynn talk about this, and I think it would not hurt. We've got a lot of empty real estate on the very first page of the website, and I think it wouldn't hurt to even have like a subtitle, Digital Scriptorium, like underneath that, an online resource to find manuscripts in American collections. Just somehow get it right up there to let people know what is this thing trying to be, so that they don't think it's trying to be something else. And because and even then, the whole point of the rebuild was to sort of decentralize the whole architecture of the not just the catalog, but the workflow, everything about it was to decentralize things and to send users ultimately to the institutions that own the manuscripts. And so I don't know, you could work on the language of that, but like I said, if you go to the front page of the catalog, it has a lot of empty real estate where something very succinct like that could be put up there so people understand what the purpose of the catalog is.
I don't want to, that's a great point, and I don't want to sort of like absolve us of those questions, but at the same time,
Yeah.
it does kind of emphasize that one of the things about the model and the workflows and the whole process was emphasizing, if not agnosticism, ecumenicalism, in the sense that like folks are describing these things in different ways and using different standards. Institutions are all using their own standards. They're using their own encoding formats. They're using their own, they're linking to particular vocabularies or citing different vocabularies. And so this is our attempt to make that discovery portal as federated as possible when the data is heterogeneous. That's our goal, is to be a portal as a discovery aid in a federated way. Can we reuse the data usefully to populate things like Wikidata and get a conversation started over there? Yes. Can we solve the problem of manuscript description in a post-colonial age? No, that's not what we're doing.
We don't,
Yeah.
we don't want to do it.
Yeah, we're not doing it.
Yeah.
Can I just,
There's a
I just
question
want
on
to
Zoom,
clarify
I think.
something that Jeffrey said really quickly. I just want to clarify something based on what Jeffrey said, because I want to make sure everyone understands this. It's really important that everyone understand Digital Scriptorium is not crowdsourced data. You cannot take your description of a manuscript and put it into Digital Scriptorium. Digital Scriptorium is based on an institutional membership model. So the institutions are the members, and they pay fees to Digital Scriptorium, which is what keeps Digital Scriptorium financially sustainable. So it's not a place, you could put your manuscript description in Wikibase, but not
Wikidata,
into
yeah.
Digital Scriptorium.
I didn't ask my question very well. That's not exactly, but I understand. That's a good point.
All right, so there is a question on Zoom. Well, first, Liz Teviot-Dale says, I love DS and all you're doing. So thank you, Liz. And then Cecilia Helga-Daughter says, thank you for your illuminating talk. If my understanding that Wikidata material can be edited by other people than those who originally uploaded it is correct, how are you going to ensure credibility of your material once it's out of your hands?
We don't.
We don't.
You can't. You can't. This is the nature of Wikidata, which is again different from institutional records, which is different from DS. The fact is that we put it initially out there, and I should mention that other national library projects like the Bodleian or like the National Library of Wales have done this as well. The BNF have done it. So they've already done it, and they've done it in their own way, and they haven't used, or they've used adaptations of the Wikibase, the Wiki manuscripts, the Wiki project manuscripts data model. But they're already doing it, and they're leaving it up to the public to use that data however that happens. But the point is that that there are different levels of control and different levels of description and different competing interests that are all present. But the whole point is that all of that data is accessible, and all those viewpoints are accessible, because we can say this thing is the same as this thing, is the same as this thing, is the same as this thing.
Okay, I think it's now important to give people 15 minutes to stretch their legs before the final session. But thank you very much to.
Well, it's because we're